Welcome to the second video in the Mastering Bitcoin Cash series. This part two is going to cover keys, addresses, and wallets. And we're going to be touching on chapters 4 and 5 of Mastering Bitcoin by Andreas Antonopoulos, where he talks about these private keys, and public addresses, as well as mnemonics in chapter 5. So those chapters go into some pretty deep technical detail, and I encourage you to watch those or to read those chapters. In this book, I'm going to keep it focused on software development and how to apply these concepts in code right away. So in this video, I'm going to cover private keys, public addresses, paper wallets, and mnemonics, which are also known as a HD wallet or a heuristic determinant wallet, but most people just refer to them as a 12-word mnemonic. So private keys, let's start with that. Everything kind of starts from that. The most important thing to keep in mind is a private key is just a number. And more specifically, it's a number between 1 and 2 to the 256, which is an astronomically large number. And typically the way a private key is generated is by picking a number in this number space randomly. And because the number space is so unfathomably large, the chances of any two people ever picking the same random number is very, very, very small. And so that's all a private key is. It's just a really large random number. There's no mystery to it beyond that. Now, a public key is generated from a private key, which is just a number, using a specific branch of mathematics called elliptic curve. And there's different types of elliptic curves, but Bitcoin uses a very specific elliptic curve. And then a public address is generated from the public key. So this public keys and public addresses are a thing I see developers get confused a lot. The thing you send money to is an address. It's not the public key. It's derived from the public key. And the public key is usually represented as hexadecimal. So just keep in mind they're two separate things. And the way this process works is it's a one-way road. So you start with a private key, which is random number. You use elliptic curve multiplication to get a public key, and then you hash that public key to get the address that you ultimately pay to. And the important thing to keep in mind here is that this is a one-way road. If you have the address, you cannot brute force figure out what the public key is. And even if you have the public key, which sometimes you can retrieve from the blockchain, there's no way feasibly to discover the private key if you have the public key. And it's this asymmetric that you can only go in one direction that's really powerful and is like a foundation stone of the cryptography that makes Bitcoin work as a digital ledger or a database. So private keys and public addresses together are known as a key pair. So you generate a private key, you generate the public key, and then you generate the address, and the address and the private key are known as a key pair. And one of the most important things to keep in mind is that anybody who obtains the private key can take your Bitcoin. So two people with the private key have equal and total ownership of the Bitcoin. And this is where concepts with developing software with Bitcoin kind of runs head into a wall with legal stuff, because most legal historical precedent cannot fathom the concept of two people with equal and total ownership of something. Usually like possession is ownership, or there's some other thing that determines ownership. And it's illegally like a square peg and round hole thing for two people to have equal and total ownership, where they don't need to check in with the other person. It's I've struggled with this with some of the businesses that I've helped start. So again, getting back to the practical side, we're going to jump into some code in a minute. Private keys typically use the with, or pretty much always at this point use the with format. And so you'll be able to tell it's a private key because it will start with either the letter K or L. And in the book, Mastering Bitcoin, they talk about some of the history of the different formats of keys and addresses. And they talk about different ways that private keys can be consumed by software. But effectively, today in 2024, everyone's coalesced on a standard of using the with format for representing private keys. In Bitcoin Cash, a public address has a Bitcoin Cash prefix, and that makes it very clear that you're using the Bitcoin Cash blockchain. On BTC, like legacy addresses will start with the number 1, and then there's Bec32 format, and then there's Taproot addresses. And so there's a lot of different formats. And so by putting this Bitcoin Cash prefix, it makes it like as obvious as possible to the user that they're using Bitcoin Cash and not BTC or some other Bitcoin fork. So before I get to the code, let me talk about paper wallets, because I find these things to be incredibly useful, particularly for onboarding crypto curious people. So I have a web app that I've built, paperwallet.fullstack.cash. You can go to it and it'll generate a new paper wallet every time. This is a key pair, a private key, and a public address. And it also does a simple ledger address if you want to store SLP tokens on the paper wallet, but it also works with just Bitcoin Cash. A paper wallet turns a private key, or really a key pair, into a physical object. And that's why I find them so useful, because humans are very intuitive and very good at safeguarding physical objects. And actually, let me just show you the website real quick. So here it is. It's at paperwallet.fullstack.cash. Every time I refresh the page, it's going to generate a new key pair. And if you want to get into the source code of this, and so it's designed to just print out with a normal desktop printer, and it's that easy to generate a key pair. And if you want to look at the source code, I recommend you not run this from the website. It's convenient, but I don't recommend it. What I recommend is that you run the code yourself on your own computer, and that if you're a developer, you inspect the code as well as the dependencies, and there's links down here at the bottom where you can get to the source code. So many people in the Bitcoin space discourage the use of paper wallets, including Andreas Antonopoulos, who wrote the book. And there's two really big downsides to a paper wallet. One is that anybody who takes a picture of the private key can take your Bitcoin. And that includes if you take a picture with your phone and then some government agency determines that they want to take your assets, they might be able to get to that photo somehow. So you never want to email or text message a private key, and just don't take pictures at all. That's a really important thing to tell people if you give them a private key. The other downside is supply chain attacks. And so by a supply chain attack, what I mean is that if you went to paperwallet.fullstack.cash and printed out a paper wallet, and I was a bad person, I could put in some code there that actually saved the private key, and I would have a copy of any private key of the paper wallet that you generate, and then I can take your Bitcoin. So if you're not generating the paper wallet on your own computer, then you are trusting someone to do that for you, and that's a potential attack. So those are the two really big shortcomings of private keys. I love paper wallets. I give them away as gifts to friends and family members. The thing I love the most about them is that I can give them to somebody who they don't have to download an app. They don't need to have internet. They don't need to have any electricity. I can just give it to them and they're good, and they can learn more about it, down the road, but it gets them a little skin in the game. So the solution to these downsides are really just tell them not to ever take a picture of the private key. I actually I have a laser engraver and I engrave them and I put them in an envelope and I hand them, in an envelope. That way there's no chance that the private key can get a picture taken of it accidentally. If you print out a paper wallet, you can fold it so the private key is inside the folds. And also, I strongly encourage you to generate your own paper wallet by running the software on your own computer. Don't use a web page. Wow, that is very convenient. It's not very secure. Okay, so a couple more points before I jump into the code. Mnemonics. A mnemonic is 12 words. Sometimes they're 24, but the standard's kind of coalesced around 12 words. And they're usually English, but they are available in other languages. You can't pick the words. Some people think you can just write like 12 random words out, and usually doesn't work because not all the words in the English language are in the library for generating a mnemonic. What the word ends up translating to a number. And so you put these 12 words together, you get a big number, and that's what's used to generate the private keys. And also, a mnemonic is part of a bigger concept called an HD wallet, or a hierarchical deterministic wallet, and it can generate billions of key pairs. And yet it's simple enough to be memorized. And so one of the things you can do to help you if this memorization thing is something you want to use is you can look at the library of words and pick 12 that you like that you think you can remember. Although that's a little less secure than just generating them randomly. But one of the huge societal impacts this specific 12-word mnemonic technology has had is recently in the Ukraine war, there were both Russians and Ukrainians trying to escape their countries, and they were both using Bitcoin, and some of them were fleeing the country by memorizing 12 words. And then when they got to a safe location, they had their money with them because they had the 12 words memorized and they were able to convert that into Bitcoin, sell it for local currency, and they were in a much better position than a typical refugee would be. So I think that was a really important historical point where you saw both sides, where the individuals ran away from the state mandated war and were able to take care of themselves in a better way. And the state put them in a bad situation, but they were able to partially recover thanks to this technology. So HD wallets are generated through a path that you can see down there at the bottom, and you can look in the book to get the nitty-gritty details, and there's bit proposals if you really want to get the hardcore technical details. But all you really need to know to be an effective programmer is there's a path that you give it to generate these 12-word mnemonics. And 145 is the standard path for Bitcoin Cash, and 245 is the standard for SLP tokens. One is the standard for Bitcoin, and Ethereum has one. All the major forks have a standard HD path so that you can use the same 12 words on different blockchains. So if you see these numbers, to hone in on these two types of paths depending on your application. All right, so let me give a quick code example of how you can use BCH.js or minimal SLP wallet JavaScript libraries to generate a 12-word mnemonic and some of these key pairs. So there are code examples on GitHub. If you go to the Permissionless Software Foundation's GitHub page, then the PSF.js examples are pinned here. And so if you click on this link, you can go into that repository, PSF.js examples. I'm going to open it here in a second tab. There we go. So first, I'll show Bitcoin.js. Now, this is the low-level library, so there's a little more code involved. And then I'll show you with minimal SLP wallet, which is very easy. It's like one line of code. So if you go into the BCH.js examples directory under Bitcoin Cash, applications, wallet, there is an example here called create wallet. And we can open that up and look at the code. So it's instantiating the Bitcoin JS library, Bitcoin Cash JS library, and it's using these APIs, which you can check out at bchjs.fullstack.cache, where you can look at the API documentation for this library. There's also a lot of information in the README on the NPM page. But so it's generating a 12-word mnemonic, and then it generates a root seed, which is just a buffer, and then a master HD node. And here's that path that I was talking about that you have to feed into it. And then it derives the first key pair on the key ring. So I was saying this can generate billions of key pairs. And then it converts it to a cache address, which is the public payment address, and then a WIF, which is a representation of the private key. And then it displays it on the console. And then down here, it actually writes the information to a file. So I've got this code pulled up in the terminal here, and I'm going to run this create wallet script. I don't need to make any modifications other than installing the npm dependencies. So here you can see, here's our 12-word mnemonic. Here is the BIP44 root or path that we use to generate that mnemonic, and then here are the first 10 key pairs generated by that mnemonic. So here's the payment address. This is the public address that I was talking about before. And here is the WIF. And you'll notice that the WIF always starts with the letter K or L. So these are the private keys. And then I can run it again, generate a brand new mnemonic with 10 new key pairs. And like I said, the number space is so big that I'll never get the same one. Lots of other people can run this software. They'll never get the same key pair either. So this is how you can very quickly and easily generate key pairs. This is basically each line here is equivalent to a paper wallet. Now let's look at minimal SLP wallet, which is much easier to work with. So again, it's in the same repository, but it's in minimal SLP wallet. And go to the create wallet example, and we can take a look at this code. So here it's imported as SLP wallet, and then we instantiate it as wallet. And so we instantiate the wallet, and then we wait for the wallet to load, which is a promise. And then we write out the object wallet.info, the wallet.info property. And so this is much faster and easier and much higher level. So you're just creating a brand new wallet, and it's doing the same thing as the code I showed with BCHJS, and that's actually what's running under the hood. And so I have that script here in this terminal window. And so if I open it up, what it does is it generates the wallet and writes it out to this wallet.json file right here. And so we can see here, there's the 12-word mnemonic, there is the public address, and there is a private key. And then there's also the public key, which is represented here in hexadecimal. Now, a lot of times people don't use the public key because it can be generated on the fly from the private key, and it's not really used for very much. I use it in some other exotic applications, but it can always be generated on the fly if you have the private key, and it ultimately generates the payment address, which is the thing that's important. And so this is an SLP wallet, so it uses that 245 HD path. And so if I run the script again and look at that file, you can see it's a brand new, different 12 words, different private key, different address. So again, I can do this as many times as I want, and I don't need an internet connection to do this. This is just a math equation, so it doesn't require internet access to do this, to generate a paper wallet or to generate a wallet in this JavaScript software. All right, well, that's the video. Thank you for watching. In the future videos, we'll move on to additional chapters in Mastering Bitcoin.
Thank you for watching to the end. My goal is to increase crypto education and to help more developers build software using blockchains. I do produce these videos for free, but I do have expenses. And so if you'd like to support me, I do accept crypto donations. The QR code on the left is for donating Bitcoin Cash, and the QR code on the right is for donating to other cryptos at cointr.ee/trout. Thanks for watching, and I'll see you in the next video.